Hello dear Group 1 students, today we will start lesson 1 in unit 2. In this lesson we will talk about form of electricity called electrostatic. Let's start. Firstly, we know that the atom is neutral because the number of positive proton equal the number of negative electron. Okay, what happens when the balance between them is disturbed? Become unbalanced, number of positive charge not equal number of negative charge. What happen? Form of electricity will produced called electrostatic. Okay, how this imbalance will occur? A imbalance between positive charge and negative charge. How this type of electricity will produced? We have two ways to produce it. Number one, by friction between two objects. Number two, by contact between two objects. Firstly, we will start with friction between two objects. Look at this activity. We have ebonite rod. Ebonite is a material like rubber. And we have a piece of wool. And we will rub them together. Make a friction between them. Okay? Then close the ebonite rod to paper pieces or paper scraps. What happened? What can you observe? The paper scraps will attract it to ebonite. Why? Why attract the paper? Because when rub them together, rub ebonite root, this ebonite and piece of wool, some charges transfer from wool to what? To the ebonite. That accumulate on the surface of ebonite. These charges accumulate or settle or collect on the surface of ebonite. So the ebonite become what? Become negative. And wool that lose electron become positive. Okay? These charges, positive and negative, called electrostatic charges. So what the meaning of electrostatic charges? They are charges that accumulate on the surface when lose or gain electron. Wool lose electron and become positive, and ebonite gain electron and become negative, and this charge is called electrostatic. Okay? So the ebonite attract paper scraps when close to them. Number two, repeat the previous step using a copper rod instead of ebonite rod. What can you observe? The paper scraps not attracted to copper. Why? Why not attracted to copper? Because the copper is conductor material. Conductor. That means what? Allow electricity to flow through them. Look at this. When wrapped with a piece of wool, the electricity or charges will pass through it. There is no charges accumulate on its surface, so it will not attract paper scraps. Okay? So we will divide the material to electrically conducting material and electrically non-conducting material. Electrically conductor like carbon and metal that allow electricity to flow through them. So there is no charges accumulate on its surface, no electrostatic charges on its surface, so it will not attract paper to it. Okay, look at this. One, the condition that a charged part is insulated to prevent the leakage of electric charges. That prevent leakage of electric charges. But electrically non-conducting material that's called insulator, like wood, paper, wool, silk, glass, ebonite. All of them, the charges will accumulate on their surface, so they can attract the paper to them after friction with another object. Okay? Look at conclusion. Wrapping certain object like ebonite with a suitable material like wool give them the ability to attract lightweight object because they have being charged with static electricity or electrostatic charges. Okay, the electric charges settle on the surface of the wrapped part of the object only and don't transfer to the rest of it. The charges will accumulate on the wrapped part only. Okay, wrapped part only, but the rest of the ebonite don't have these charges, so don't attract the paper. And rubbing or friction between objects like copper don't give them the ability to attract lightweight objects or paper scraps. Okay, so we know that the charges accumulate on the surface. That happen due to what? Due to friction between two objects, and this charge is called electrostatic charges. Look at this question. Give reason. Feeling a slight electric shock when you're touching a metal door handle after walking barefoot on the carpet. After walking on the carpet and touch metal handle of door, you will get electric shock, light electric shock. Okay, why? When you walk on the carpet, there is friction occur between you and carpet, right? So some charges transfer from the carpet to your body, and when you touch the handle, metal handle, this charge will discharge it. Discharge it, that means transfer, okay, or go away from your body, okay? So because when touching the handle, the charge formed on the body is discharged as a result of friction with carpet. Okay, when you walk, there is friction occur between you and carpet, so charges accumulate on your body. So when you touch the handle, these charges will discharge it. Okay, number 2, hearing a slight crackling sound when taking off woolen clothes in winter. When you take off the clothes, will you hear sound like a crackling sound? Okay, why? Because there is friction occur between you and clothes, woolen clothes. Okay, so some charges accumulate on your body. When you take off the clothes, what happens? These charges will discharge it or go away from your body. Okay, so you hear this sound because on friction with the woolen clothes, electric charges formed on body are discharged. And we said this type of charging called charging by friction. It's a process of charging two uncharged objects by rubbing two objects together. We have two objects uncharged. They are neutral. When rub them, some charges transfer from one to another. So electrostatic charges will form it. And this type of charging called charging by friction. What happens when two different objects uncharged are rubbed together? We have two uncharged objects rubbed together. Electrons will transfer from atom found on the surface of one object to the atom found on the surface of the other object, causing both become electrically charged with equal magnitude of a charge but opposite in type. One of them will lose electron and become positive, and the other will gain them electron and become negative. The charges equal in magnitude or value but differ in the type, one of them positive and the other negative. The objects that lose electron become positively charged, but the objects that gain electron become negatively charged. So what is the meaning of static electricity or electrostatic charges? The charges that accumulate on the surface of object when they lose or gain electrons. Okay? And this week electric charges are measured using a device called coulometer and measured in unit called coulombs. Okay? Look at this picture. We have a piece of silk and a ebonite root. When rub them together, the silk will lose electron and become positive, and this electron will accumulate on the surface of ebonite and become negative. Okay, look at this scientist. He called Coulomb. Okay, he is a French scientist who formulated the law describing electric forces between charged particles, named after him, Coulomb's law, also known as inverse square law. Coulomb made a law called inverse square law or Coulomb's law. This law describes the electric forces between charged particles. Okay? As we said, when wrapped two objects with each other, one of them lose electron and become positive and the other gain this electron and become negative. Okay, how we will know any matter will lose electron and any matter will gain electron? The scientists make a series called electrostatic series. In the series, they arrange the material according to easiness of losing electron. Okay? That mean what? This is series start with glass. That mean glass is lose electron easier than wood, and wood lose electron easier than leather, and leather lose electron easier than silk. For example, when wrap glass with leather, we said arrange it from easier. So the glass higher in the electric series will lose electron and become positive, but leather lower than glass in the electrostatic series will gain this electron and become negative. Okay? So the electrostatic series arrangement of material according to the easiness to losing electron when wrapped together consists of what? Glass, wood, leather, silk, wool, cotton, paper, ebonite. Look at this question. What is the type of a charge formed on each piece of thin stick leather and wooden rod when they are rubbed together? Explain. We rub leather, thin stick leather, and wooden rod. Look at the series. Wood is higher than thin stick leather. Okay, so the wood will what? Will lose electron and become positive, but leather will gain this electron and become negative because the wood is higher in the electrostatic series. As we said, the higher will lose and the lower will gain. The thin stick leather become negatively charged and the wooden rod become positively charged because electron transfer from what? Wood to thin stick leather. Look at this question. Which of the following material acquire? Acquire that mean get or gain. Get a negative charges when rubbed with a piece of wool. Okay, we have some choices. Number one, silk. Look at the series. Wool lower than silk. So when rubbed together, silk will lose electron and become positive, not negative. So it's false. Number two, cotton. Look at the series. Wool higher than cotton. So when the wool rubbed with cotton, it will lose electron and become positive, and the cotton become what? Negative. So it's a true choice. Give reason. A single material can be charged with either positive or negative charge. One material may be positive or negative. According to what? That depend on the type of wrapping material. Okay. For example, silk. If we rub silk, okay? If we rub silk with wood, what happened? Wood higher, so the wood become positive and silk become negative, right? طيب, what happened when the silk rubbed with paper? Paper is lower than silk in the series, so the silk become positive and paper become negative, right? So the same material may be positive or negative according to what? The wrapping material. That depend on the type of wrapping material. Because that depend on the type of wrapping material and its order in the electrostatic series. If rubbed with material higher in the series, it become negatively charged, while if rubbed with material lower than in the series, it become positively charged. Okay? Now we will talk about the electric forces between the object. Okay? The electrically charged object exert mutual force on each other, which differ in type depending on the nature of charges on this object. We have two types of forces, electric forces, a repulsion or attraction. Okay, if the object have the same type of the electric charges, two objects have the same type of electric charges, so repulsion force arise between them. If we have two objects have same charges, but if we have objects with different charges, one of them positive and the other negative, so attraction force arise between them. So we have two types of electric forces, repulsion or attraction. Look at this activity. We have two ebonite root rubbed with a piece of silk. They both rubbed with a piece of silk. So they both will have what? Same charge. And the silk higher than in the electrostatic series. So it will lose electron and become positive, but ebonite will gain electron and become negative. So the type root, ebonite root, will have same charge that called negative charge. So what happened? What is the force arise between them? Repulsion force, because they have the same charge. If you approach one to the other, the suspended freely will move away from the other ebonite root because it has the same charge of it. So repulsion force arise between them. Number two, if we have two glass root and rubbed with a piece of silk, what happened? Glass is higher than silk in the electrostatic series, so the glass will lose electron and become positive, but silk gain this electron and become negative. And the two glass root have the same charge that called positive. So what happened? Repulsion force arise between them. Number three, when you close a glass root with ebonite root after rubbing with silk, we said when rub ebonite it will have a negative charge, but when rub glass it will have positive charge. So they have different charge, so attraction force will arise between them. Okay, so again we have two forces, attraction or repulsion. If we have same charge, the repulsion arises between the object. If we have different charge, the attraction arises between this object. Scientific prediction: predict the path of beam of subatomic particles. We talked about subatomic particles in Unit 1. They are particles found in the atom called both positive proton, negative electron, and neutral neutrons. Okay? This beam will pass through two plates, one of them positive and the other negative. Okay? What happened? We said the different charges attract to each other. So the electrons which have the negative charge will go to what? Deviated to what? Deviated to positively charged plate. But proton that have a positive charge will deviate to negatively charged plated. We said the different charge attract to each other. Okay? But neutrons will pass without any deviation because it's neutral, don't go to positive or negative. Okay, look at the explanation. The electrons are deviated toward the positive plate because they are negatively charged and the different charge attract each other. And the neutron pass in a straight line without any deviation because they are neutrally charged. But proton will deviate toward negative plate because they have positively charged, and the different charges attract each other. Okay, life application of attraction of opposite electric charges. We use this force in something in our life called electrostatic plating. Its importance to plate metals. Okay, color them. Its working idea: the object to be plated, we want to plate it, will be charged with negative charge, and the paint spray will be charged with positive charge. So the spray will have positive charge and object to be plated will have negative charge. So what happened when you spray it? What happened? The paint will attract to the object because the paint has what? Positive charge, and a object has negative charge. The paint particles are attracted to the object to be plated due to the difference in their charge. And the advantages of this process: number one, ensure an even layer of paint. Number two, reduces the paint wastes. Now we will solve these questions. Number one, each of the following materials attracts paper scraps after being wrapped with wool except wood, gold, or silk. We will choose gold because it's a metal, so it's conductor material, so there is no electrostatic charges accumulate on its surface, and it will not attract paper scraps. Number two, what happens when an ebonite root is rubbed with piece of thin stick leather? We said in the electrostatic series the leather higher than ebonite, so the leather will lose electron and become positive, but ebonite will gain this electron and become negative. That means electrons transfer from what? Leather to ebonite. So we will choose B. Number three, which figure represents the electric force between two balloons charged by wrapping them with a piece of cotton? The both will wrapped with the same material, that's cotton, so the both will have what? Same charge. And we said same charge, if object have same charge, repulsion arise between them, so we will choose C. Number 4, which of the following subatomic particles are not deviated when passing between charged plates, and why? If we have two plates, one of them positive and the other negative, and subatomic particles pass through them, electron will deviate it to positive plate, but a proton will deviate it to negative plate, and the neutron will not deviate to any plate because it's neutral. So we will choose number C, neutrons, because they are electrically neutral. So they pass in a straight line without any deviation. The next, a person's body acquires a charge when walking barefoot on a carpet. Why does person's body acquire a charge? Why? Due to what? Friction between you and carpet, so some charges transfer to your body. Number 2, what happened when this person touch a metal object connected to the ground? What happened? We said the charges on your body will discharged. That means go away from your body. So you will feel what? Slight electric shock.